Hello and welcome. Okay, we are going to do IGCSE Mathematics. The topic for today is bearings. So today we will develop some basic understanding and then we will also see how we are going to be assessed in a Cambridge paper 4 calculator version. Okay. So any student have idea what does bearing means and what does this photo in the circle represents? What are these blue dots? Just take a wild guess. We are going to find out soon what how interesting this photo is and what does you will be very surprised. So bearing is a concept that we developed to find directions. Actually, the concept of bearing was developed by sailors when they used to go to sea and there is no direction. How do we measure directions nowadays? We just open our mobile phones, we use Google Maps, GPS, but GPS was just developed in 1978, very few years ago, a few decades ago, and it became common very recently. So, how did people find directions in the sea or in the air, airplanes? They used the concept of bearings. Okay, so compass was discovered thousands of years ago. You can see a compass here. What is a compass? Compass tells us the direction. You can go to any place in the earth, in the jungle, in the sea, in the desert. Compass will always work. It will always show you where is the north, where is the south of the earth, where is the east, where is the west. All right. So, what does bearing do? Bearing tells us the direction of travel. So it's a very real life application topic that we are going to understand today, discover today. Right. So here you can see a simple diagram. Here's a lighthouse and there is some ship. Through the help of bearing, we can determine if the ship wants to reach the lighthouse. We can actually find out in what direction it needs to go just with the help of a compass. Okay, three things you need to understand to remember actually for to calculate bearings. First of all, north direction from the compass. The north is the most important. Our reference point is the north from any point. You just look at the north. So these arrows on the right, they are pointing towards north. And it doesn't change. The north of the earth is fixed, right? North pole, you know the north pole. Okay. Then the angle. Bearing is angle basically. So angle can be measured in clockwise direction or in anti-clockwise direction. Okay. So we pick and keep it fixed clockwise direction. So whenever you are measuring the bearing, which direction you will choose? Clockwise from the north. However, where do we stop? We will stop till we reach the line joining the two points or the two places. For example, on the right, there is a line that is connecting the lighthouse and the ship. All right. So we start measuring the angle using protractor. Okay. From the north on the ship, the reference point, we are measuring the angle, the bearing of lighthouse with respect to the ship. Okay. So you can see that we went clockwise. Straight line angle is 180 and then there is another 70. 180 plus 70, 250. So the bearing of lighthouse from the ship is 250-degree. Okay. No worries. Let's look at more details. Okay. That's just an introduction. Any questions? Let's look at further. What do we have here? Is it only ships and sailors using bearings? When we invented airplanes, airplanes also use bearings. Actually, now I'd like to go back to the title slide. What are these blue dots? Actually, this is a screen of an air traffic controller who wants to become a pilot or work at an airport. We love airports. So whoever wants to work as a pilot or as an air traffic controller, what an exciting job, right? This is the kind of screen you see on the computer. So all these blue dots are actually airplanes flying in the air. And if you zoom in, the numbers on the blue numbers 56, 304, 360, these are the bearings of the airplanes. So in the air, there is no GPS. Okay, there could be. Now the airplanes are very developed, but the bearing remains applicable. All right. All these numbers indicate their direction of travel in the form of bearing. All right. And one more point before we move on to next slide. Bearing is measured from 0 to 360 degree. But there are some conventions. If the angle is less than 100, you put a 0 next to it. Okay. Not next, sorry, before to it. Okay. For example, if the bearing is 70 degree, in this slide, in this equation, the bearing is the 70 degree is the bearing of ship with reference to the lighthouse. Okay, so the clockwise angle is 70 degree, but just say it the bearing is 070. All right, or 070 degree. We use 3 digit to avoid any confusion. All right, 70, you can call it 070. So here are the two planes in the air. Okay, and I have made a simplified diagram on the right side, which you will see in questions. This kind of diagram, not 3D diagrams or like graphs. Okay, so what is the bearing of plane B from A? The keyword is from. Whatever letter will come after the from, you have to draw the north on that. Okay. So if I ask you what is the bearing of plane B from A, immediately go to the north of A first of all. All right, and then see the clockwise angle till you reach the line joining the AB points. All right, so that is 75 degree. But remember, if it is less than 3 digit, we'll just put a 0 in the front. All right, any questions, any doubts? Okay, then one more thing, we are going to regularly use interior angles while calculating these bearings. Okay, the reason is both of the norths at any points, obviously they are in the same direction, so they are parallel lines. Remember, interior angles were the one which make a C shape, right, which are locked between the parallel lines. Okay, and what are interior angles? What's special about them? Their sum is equal to 180 degree, right? For example, in the top, G and H, the sum of G and H is 180 degree, right? So we can apply that here. If the left side angle is 75 degree, the green angle I have calculated myself. How I got it? Since both are interior, so you can just subtract from 180 75 degree. Okay, so the green angle is 105 degree. Why we need the green angle? In order to find the bearing of plane A from B. So to find the bearing from A from B, we need to draw the north on B now. Okay, and from the north we used to find that red angle. The red angle is our answer. But how do we find it? How do we find it? Subtract from 360. You know that the full circle angle is 360. So from 360, you can just subtract 105, and there you have the bearing of plane A from B. Okay, so with respect to B, sorry, with respect to A, the B is traveling at 255 degrees. So like this, the planes can communicate their positions with each other and avoid collision. Very important. All right. Any questions? So after that, at the end of the lesson, we are going to solve one question from paper 4 of IGCSE. All right. So this is going to be a mix of trigonometry and bearing as well. Trigonometry concepts in the question, they will be, inserted, they will be combined with bearing. Okay, you can expect them to be together. Okay, so before we solve this question, remember you have to use here sine rule also that you must have studied in the trigonometry chapter. Anyone can tell me the sine rule? Yes, sine A over A, the opposite sides, they work in pairs. An angle in a triangle divided by the sine of that. Okay, so we'll move to sine rule later. First of all, please read the question. So L and K are sorry, K and M are two ships, and L stands for the lighthouse. So we have a diagram. These are all in the sea. All right. The bearing of L from K is 155. We have to label that. It's not labeled on the diagram. Whenever you start the question, first of all, please label the diagram with the data given in the question. Okay, that's very important. So in the next slide, you can see that I have labeled the first thing. Just focus on one thing at a time, no worries. The bearing of L from K is 55. That means the north will be on K. So there is already a north on K, and you go clockwise till you reach the line joining K and L, and that is 155 degree. Okay. KL is equal to 112. It's already labeled there. Fine. The bearing of K from M is 10 degree. K from M. So the north, this time, what should we be looking is the north on M point. All right. And when you go clockwise, that small angle in green color that I showed 10 degree. All right. I just labeled it 10, although in bearing is 010. See, they are following the convention, 3 digits. All right. Any question in labeling or seeing the bearing on the diagram? No problem, right? KLM is 96 degree. That's there. No problem. We already know. Find the bearing and distance of M from L. Okay. We'll move to distance in the next slide. I think, sorry, I have to show you this slide first. This slide is about the finding the bearing. That was for the distance. Let's do this one first. So first of all, bearing of M from L. So we should have a north on L. Okay, so that's the blue line, the north on L. There should be an on the top, by the way. Okay, so we have to go clockwise until you reach the line joining the M and L. Okay, the ship M and the lighthouse. So that I have labeled that big angle, that reflex angle, as X degree. That's our target. So in order to find that, it's a bit long question. Okay, stay with me. So first of all, what we can do, we have found this. Okay, which one first? Yeah, 25 degree. How we'll find that 25 degree? Interior angles, right? That north on K and north on L, they have the same direction. So if you subtract from 180, 155, you have 25 degree. So here you have that green angle. Okay, take it as a game. Find as many angles as you can. Okay, so since you have 25 degree, now you have another pair of north. Now you will look at the green, the yellow part, please. All right, look at the north at M and at L. At M, the full angle is 96 plus 10. If you subtract that from 180, you will get the full angle. Okay, and also subtract that 25 degree, you will get that yellow angle 49 degree. Okay, because both all of these are interior angles. So you see how critical interior angles are. Okay, in the bearing questions. From 180, subtract that 96, subtract that 10, subtract that 25 also, and you got that small angle inside the triangle, which is 49 degree. Got it? And now it's very simple. The last step, from 360 degrees, subtract 49 and 25, you get the bearing of M from L, which is 286 degree. Any questions? Since you have 49 degree and 96 degree, you can easily find the third angle of the triangle, which is 35 degree. Subtract from 180, 96 and 49. After that, it's a simple case of sine rule. Sine rule, how does it work? You take any angle of the triangle, let's take 35 degree, divided by the opposite side, which is ML, which is the distance that we need to find. Okay, so just keep it ML. You need another pair. Take 96 degree. Now we can use that angle that was given to us in the question, divide by the opposite side, which is 112. Okay, all you need to do is use calculator and you can find the distance of the ship M from light L, which is 64.5. All right, so we can practice this. Okay, I'll provide you the worksheet. You can practice the questions. Okay, any questions, any doubts? I hope all is clear. Thank you for your time. I hope you enjoyed the lesson.